A beautiful life to each and every one of us. Discussion in this session is all about dynamic of rigid bodies, kinematics of particles, part 2. By the way, this is your Matinik at Musikero channel, now signing on. Before we start our discussion, please don't forget to subscribe to our channel, Matinik at Musikero. Press the notification bell so that you will be given more updates every time you're going to open your YouTube account. Let's start our discussion. Start with our example number 1. Given an equation of motion, x is equal to 6t squared minus t cubed. To solve it, we have the following questions. What are x, v, and acceleration at time of 2 seconds? The second question. What are x, displacement, v, velocity, and acceleration at time of 2 seconds? In order to calculate, and in order to have our graph to solve for some coordinates, to start with, let us try using the time of 0 second. Time 0 second. Let us use the equation of our motion. X is equal to 6t squared minus t cubed. Substitution. X is equal to 6 times 0 squared minus 0 cubed is equal to 0. We have our ordinate as 0 and abscissa of 0. Our first coordinate now is 0 and 0. Let's move to our second coordinate using the time of 2 seconds. Since our question goes like this, what are x, v, and acceleration at time of 2 seconds? So let us use 2 seconds. Our time. Time of 2 seconds using the equation of motion by substitution from x is equal to 6 times 2 squared minus 2 cubed equals 16 meters. We have our second coordinate as and 16. Now let us have a try for 4 seconds. Time of 4 seconds is substitution. X is equal to 6 times the square of 4 minus the cube of 4. We have 32 meters as our coordinate. Now we have another coordinate. We have 4 and 32. Let us have another try by using the time of 6 seconds. Again by substitution to the equation x is equal to 6t squared minus t cubed. We have our equation now as x is equal to 6 times the square of 6 minus the cube of 6. We have a value of 0. Now let us have our sketch of the graph. Let us have our figure. For our first coordinate, we have 0 and 0 by using the time of 0 seconds and having an ordinate of 0. For our second coordinate, by using the time of 2 seconds and having a result of 16 meters, we have now our coordinate as 16. For the third one, by using the time of 4 seconds, we have calculated for the value of x as 32 meters so that we can have the coordinates of 4 and 32. And for our last coordinate, by using the time of 6 seconds, we have calculated for the value of x, which is equal to 0. It is also our ordinate. Now we have the coordinates as 0 and 0. And for the continuation of our solution, let us have now the derivative of our x equation with respect to time, so that we can calculate for the value of our velocity. Velocity now is equal to the derivative of x with respect to time. It is also equal to 12t minus 3t squared. Because the derivative of 6t squared is 12t and the derivative of t cubed is 3t squared. By using this equation in our next slide, again we have v is equal to dx over dt equals 12t minus 3t squared. Again, Let us have more coordinates for a new sketch of the graph by using the equation b is equal to 12t minus 3t squared. Using the time of 0 seconds to solve for the velocity. Velocity now is equal to 12 times 0 minus 3 times the square of 0, which is equal to 0. We already have our first coordinate as 0 and 0. Let's have another coordinate by using the time of 2 seconds. b is equal to 12 times 2 minus 3 times the square of 2. We have a value of 12 meters per second. So that we can have another coordinates as 2 and 12. Let us have another try by using the time of 4 seconds. Let's calculate for the value of our velocity as our coordinate. v is equal to 12 times 4 minus 3 times the square of 4. We have a value of 0 as velocity. Report 1. Let's try a time of 6 seconds. What is then the velocity value? b is equal to 12 times 6 minus 3 times the square of 6. We have a negative 6 value, our velocity. We have already completed all the coordinates that we need so that we can sketch the graph of our equation of motion. v is equal to 12t minus 3t squared. So as you can see, we already have our graph. Let's start first with our first coordinate. By using the time of 0 second, we have the coordinates as 0 and 0. Our second coordinate, we have used the time of 2 seconds so that we can have a velocity of 12 meters per second. I think this is the maximum velocity that we can have. Coordinates, we have 2 and 12. Our third coordinate, by using the time of 4 seconds, we calculated the velocity of 0. Its coordinates are 4 and 0. Our fourth coordinate, time of 6 seconds, using velocity is equal to 12t minus 3t squared by substitution, we have calculated value of negative 36. Now we have the coordinates of our equation. 6 and negative 36, the coordinate of our given point. What are x, velocity and acceleration at time of 2 seconds now? Time of 2 seconds, obviously, x is equal to 16 meters, as we have calculated for our previous slide. Velocity is 12 meters per second when time is equal to 2 seconds, as we can see in our graph. Meaning, velocity 12 meters per second is our maximum velocity. Apparently, the acceleration here is equal to 0. Note that maximum velocity occurs when acceleration is 0 and at the slope of the velocity of 0 at this point. For our next slide, for the continuation of our computation. Let's proceed now to the acceleration. Acceleration is equal to the derivative of velocity with respect to time, or its second derivative with respect to x, with respect to time. For the second derivative of x with respect to time is equal to 12 minus 6t. Now, let us solve for sets of coordinates again. By using the time 0 second, let's solve for the value of our acceleration. Acceleration is equal to 12 minus 6 times 0. And we have a result of 12 meters per second squared. Let's have another try. Time of seconds is substitution to our given equation A is equal to 12 minus 6t. A now is equal to 12 minus 6 times 2. We have an acceleration of 0. Time of 4 seconds. acceleration is equal to 12 minus 6 times 4, so that we can have a value of negative 12 meters per second square, meaning there is a deceleration. For the fourth one, time of 6 seconds, acceleration is equal to 12 minus 6 times 6. We have a negative 24 meters per second square value. Now we have already completed all the coordinates that we need so that we can sketch the graph by equation of motion. In terms of acceleration, time. Let's have now sketch of the graph. Start with our first coordinate. By using the time of 0 second, we have calculated an acceleration of 12 meters per second square. That's why we have our coordinate as 0 and 12. See to the next coordinate. Time of 2 seconds, we have calculated an acceleration value of 0. That's why our coordinates are 2 and 0. The third one, using the time of 4 seconds, we have calculated for the value of our acceleration as negative 12. That's why we have our coordinates as 4 and negative 12. For our fourth coordinate, time of 6 seconds is equals to negative 24. So our coordinates then are 4 and negative 24. What are x, displacement or distance, and v or velocity, and acceleration at time v seconds? I think this should be per seconds. Since the variable v to a number 4, let's correct it. So this must be 4. And for the confirmation, time of 4 seconds, x maximum is equal to 32 meters. So you can see this from our previous slide. X maximum or distance is 32 meters, and then the velocity is equal to 0. Acceleration is negative 12 meters per second square. God is truly great. God is good and generous. Thank you very much and thank you for watching. Buhay ang bawat kabataang Pilipino.